Hello, so the first problem I chose was question number 8, and it states the current in a series circuit is 20.4 amps. When an additional 8.78 ohm resistor is inserted in the series, the current drops to 16 amps. What is the resistance in the original circuit? So for this problem, we're given amps, or we're given the current and resistance, and so I know that we will be using Ohm's law. And Ohm's law is V equals IR, where V is the potential difference measurement, which is the measurement of voltage between two ends of a conductor, and the SI units is volts, and then which would be V, and then our I would be current, which is the rate at which charges pass a given cross section, and the SI units is amps, also known as A, and then R is the resistance of the conductor, and the measurement of the materials. And it's the measurement of the material's resistance to electric current, and the SI units is ohm. So for this, I went ahead and drew the images of the original and then compared it to the second one, which helped a lot because for this problem, we basically had to use algebra, simple algebra. And so we know that in a circuit, we're going to be going from our positive end to our negative end. And so I went ahead and drew that, and that would be our current. And our current is 20.4 amps. So we know what our current is. And then we know that we have a resistance because it says it's a series circuit. And also it says to find the original resistance. So that's how we know we have a resistance somewhere in here. And then we're told that when we add another resistor, when the additional 8.78 resistor, ohms, which would be ohms, is added. So I know this is my original resistor right here, and then this is my second resistor, which is 8.78 ohms. And then I know they're in a series circuit because it tells me. And then right here, and it says our current has changed to 16.0 amps. So what is the resistance of the original circuit? So we're trying to find this R right here, this original one. So, and I went ahead and draw the positive to the negative sign because this is our current. Only the current has changed. Well, and our addition of resistance. So I first put together the formulas for both sides because we know certain parts to each formula of each side. So basically I had to do algebra for this. So I rearranged it to where I would solve for V, and just to be able to plug V into this equation. So first of all, I did V equals IR, which is Ohm's law, and I just manipulated the equation, which is kind of silly of me. But now we're at, I changed it to I equals V over R because I changed things around to figure out which was easiest to input into here, and vice versa. So I realized that V would be easiest to put into here. And also doing that would give me R. So first of all, I did for the first circuit, our current is 20.4 equals V over R. So we don't know both of these things. So I rearranged it to where we have V that's alone. Because I got V equals 20.4 R because I multiplied R to get it over there. And then over here, I did the same thing. I did current I equals V over R right here. And I left V alone up here. And then I just took this whole equation and brought it down here. It's because I have my V solved already. So I plugged in my V of my original equation and plugged it into the second equation to be able to get 16 equals 20.4 R over R plus 8.78. So what I did was I multiplied this whole section over here, and then I multiplied it out. So I did 16 times R, which would be 16R, plus 16 times 8.78 would be 140.5, equals 20.4 R, which is just what's left up here. And then I got my R's together, subtracted my 16R from over here, and I got 4.4R. And then I have my 140.5 left, which would then equal, or 140.5 divided by 4.4 R would be 31.9 R, but this is also ohms. So I'll just write that in. So this is our final answer, would be the 31.9 ohms R, and then I also have that in my answer up here, 31.9.